Hello, this is Dr. Scott Dennstaedt, founder of EZWxBrief, your best online source for aviation weather and education. Welcome to episode 30 of EZWxChat, a program to discuss various topics related to aviation weather. Well, thanks again, everyone, for listening in. In this episode, I'm going to kind of change gears a little bit from what I've done in the past. I know anytime there's an aviation accident where weather may be related, I do get a few emails or phone calls and text and such that kind of ask me about what might be going on. And I search some of the various different aviation weather forums for discussions on this, as well as other YouTube videos out there that may start to discuss this particular accident that occurred. And we know that these accidents have to go through a lot of review, but there was a specific accident that occurred just west of St. Louis for a Baron, and again, I got notification. There was a specific YouTube video out there that indicated that this particular accident was related to icing. And I'm not going to go into and not going to tell who this YouTuber is for this particular session. It's really not the driving force of me making this particular video. It's to cover and analyze the weather on that particular day. But in this particular video, there's a lot of information that is just ill-conceived. It's pretty bad, and the sad thing is that this particular YouTuber evidently has a lot of followers. I didn't know this person, but evidently he's got a ton of followers, and he's pushing out all this misinformation. Imagine that on YouTube, misinformation. So that's the kind of the story that we're looking at here in terms of trying to analyze what happened, and kind of going off on a number of different websites that I've seen out there, aviation forums, that try to make this into a weather-related accident associated with icing. So that's the kind of thing I'm looking for in this particular scenario. So let's kind of look at the accident itself, and I'll mention a few things that were kind of related in this video so that you can kind of understand where I'm coming from that particular standpoint. So I've documented this on my live training site, EZWxTraining.com, and in my blog. And you can get this from the EZWxBrief as well by going to the home page, and there's a link there for the blog itself. And in there, I've developed a post I produced about a week ago, and I went through this analysis, and I'd like to go through that and provide a little bit more color behind essentially what's going on. And essentially, this accident here occurred back on January 8th, but it's a Beechcraft 58 Baron, and they both were fatally injured in this accident shortly after departing the Spirit of St. Louis Airport just to the west of St. Louis. They departed in the evening at 7:10 p.m. Central Standard Time. They were headed to Centennial Airport in Denver, Colorado. Again, what I'm about to talk about in terms of the weather depiction obviously could contain errors or omissions. I think it's pretty solid overall, but the NTSB will have to go through its formal investigation and provide the details and submit a specific cause. Now, I didn't see the NTSB. Sometimes the NTSB comes out and gives press releases, or at least appears on TV, and evidently there was some mention, I don't know if this is correct or not, but there was some mention that the NTSB ruled out icing as a possible accident. But this particular YouTube personality suggested from the beginning, without really looking at the data, that this was an icing accident. And specifically, this YouTuber pushed out and allowed us to listen to the ATIS that was broadcast out of Spirit of St. Louis, which included an indication of the temperature and dew point at the surface, which was 7 degrees Celsius and 6 degrees Celsius respectively. And immediately following playing of that, this particular individual said, taking off into freezing drizzle conditions. Well, number one, there was no mention at all of freezing drizzle in that ATIS, and I'll show you the surface observation in a bit. So I'm not sure where this person gets that information from, and ends up saying, you know, as it's colder as you climb. Yes, eventually it does get colder as you climb, and we'll dig into that in a bit more. But that may not always be the case. Too many pilots leap to the fact that it's 7 degrees Celsius at the surface, so therefore, you know, 3,000 or 4,000 feet above the ground, the freezing level is met. And that's may be true in some situations. It may not always be true. So it doesn't always get colder as you go aloft, but eventually it will, in the sense of when you get much, much higher in the altitudes. Yes, it does eventually get colder, but there may be layers we call inversions that we'll talk about, where the temperature actually gets warmer with height. So you never want to start off with an indication that it always gets colder as you go up. And in fact, he even goes and says further in this YouTube video that it does not get warmer as you go up. And he couldn't be further from the truth in this case. And then he goes on to say that this particular airplane iced up like a popsicle without providing any proof of that. There's absolutely no proof that that occurred. In fact, it is extremely unlikely that occurred in this particular case. And, you know, I'm pretty much convinced myself that this had anything to do with any kind of airframe icing. So could be something else associated with weather in terms of disorientation, or a lot of other things could occur that could be weather related, but airframe icing was extremely unlikely in this situation, and I'll show you why that's the case. So you can see here, this is the FlightAware Track that we're showing up here, and it simply provides a pretty good indication that shortly after departure something went awry. Now keep in mind that this particular depiction of NEXRAD that you show on FlightAware is not necessarily at this particular time. So you have to make sure that you understand that just because you see, so this is 10:15 p.m. Eastern Standard Time, which would be Central Time would be 9:15 p.m. and the flight, essentially took off at, as I said earlier, 7:10 p.m. Central Standard Time. So don't rely on the picture that the FlightAware shows in terms of the actual NEXRAD image. There wasn't much in the way of precipitation in that area at the time the flight took off. There was some areas of precip that were moving in, and yes, as the YouTuber mentions in the video, that yes, it did eventually at the accident site, it was precipitating, some rain was reaching the surface. But at the time of departure, that was not happening, and therefore, again, if you looked at, as we'll look at in a second, at the observation, there was no precipitation reaching the surface in that general vicinity. And when you see these kind of FlightAware tracks, you also want to look at the vertical track, and essentially the pilot was climbing up to the cruise altitude of 8,000 feet and reached that altitude when things again weird things start happening. And we don't know if there was a loss of an engine or maybe there's an incapacitation problem. We don't know. There is certainly some air traffic control audio that was really hard to hear, so it's unsure with how that was captured, whether or not we'll be able to hear the details. But certainly when they do the formal NTS briefing, that will come out, and we'll know more about what transpired between air traffic control and the pilot in command. So once again, the ATIS at the time of departure, really close to around that. This was essentially at 107 Zulu, so pretty close to the time of departure. The winds were from the south. That's kind of important here. 190 at 7 knots, a 2 statute mile visibility in mist, overcast 1,000, 7 degrees at the surface, 7 degrees, positive 7 degrees, and with a dew point of 6 degrees. So very moist conditions at the surface. And there's your altimeter, and the ceiling was variable from 800 to 1,300 at that particular time. So when you look at 7 degrees, as I say here, is that it's common for a lot of pilots, because this is the way they're taught, unfortunately, that you go up in altitude and the temperature decreases. They're often taught to use the standard lapse rate to do that. And if you were to apply and use the standard lapse rate here, given the field elevation of 463 feet, and you go up 1,000 feet, you lose essentially 2 degrees altitude per 1,000 feet standard. That's not the actual lapse rate in the atmosphere. It's actually what is considered the standard. We know the atmosphere is almost rarely standard. So, and when it's not standard, that produces some interesting weather that sometimes makes life a lot easier and sometimes it makes it more difficult. So if you do the math and you look at each individual altitude, you could eventually come to essentially negative conditions, negative Celsius temperatures, once you reach about 4,000 feet or so. And that would drive the fact that, sure, if the atmosphere were standard, that you would eventually reach the freezing level around 4,000 feet, plus or minus a couple hundred feet there. And so if you go back to the YouTuber's comment, yes, it's likely that if it was standard and there were moist conditions up through 8,000 feet, then icing could be a problem. So I'm not suggesting that that is incorrect, but was the atmosphere in a standard situation in this particular case? That's the real question to answer. You should not jump to the conclusion that this was an icing event without looking at the actual data. If you don't, what you end up with in a situation is you make these kind of statements, and then that gets broadcast to 50, 60, 100,000 people that watch this guy, and immediately they start blaming the pilot for making bad decisions when in fact it could have been something totally different than icing. And so I'm trying to find the right answers and trying to do the analysis prior to jumping to that particular conclusion. So this YouTuber evidently does not understand the basic principles of weather, and that's again getting promulgated out to people out there that are listening in on this, especially pilots who may be just learning. They're applying this information, and that's essentially going to hurt them in the long run. You might say, well, it's a conservative aspect of it. Yeah, that could be the case. So you say, well, I just apply the standard all the time, and that way I'm always conservative. So if it does get warmer with height, then this is conservative. And that's great, and I know a lot of people who will say that. But what happens if the lapse rate is actually greater than standard? Which, especially near the surface, we call that the boundary layer. The actual lapse rate can be greater than the standard. In that case, your standard lapse rate you're using is not conservative at all. And as a result, if you're using the standard lapse rate to calculate the freezing level, you're going to be sadly disappointed because you're going to get to a point where you're calculating that freezing level at a much higher level than it really is, causing a potential icing encounter because you're not using the actual or forecast temperatures aloft, which pilots should be using, and not using the standard lapse rate. In fact, I do mention that in here, and that is you should really never ever use a standard lapse rate to make decisions about what the temperature is aloft. For making decisions like this, instead you should use the actual lapse rate using actual forecast or in a case if you have actual numbers, for instance, a weather balloon that's launched. But in general, using forecast temperatures and dew points are much better than trying to guess using the standard. The only time it's really permitted to use the standard lapse rate is really what's called a departure from standard. If you look in your pilot operating handbook or your aircraft flight manual, there are performance tables that are usually based off of the departure from standard. And so that in that case, you're looking at the actual temperatures aloft and comparing them to the standard and then looking that up in the table. That's acceptable. But again, you're still using the actual lapse rates or actual lapse rates. You're using the actual temperatures aloft to make that calculation anyway. That's what you're trained to do. And in fact, you're required to do that according to what any training that you've had. You're required to do that. If you want to know what your ground roll is after a landing, it's based on what's happening with the weather around you and departure from standard. Endurance, how far can you fly on your tank of gas? Lots of different aspects of departure from standard that are critically important for you to look at and understand. Now, a lot of this is automated through some of the various different heavyweight applications out there, but nevertheless, it's still something you should do on a regular basis. But it involves actually looking at the forecast temperatures aloft and calculating the departure from standard. So if your flight instructor or anybody who's taught you use the standard lapse rate to calculate the freezing level, do me a favor and let them know and point them back to this and tell them that that's not a good way to provide, at least provide to for making these kind of decisions. It's not a great way to do that. So anybody who knows me also wants to probably understands that I look at the big weather picture. I see what's going on, so I understand kind of what's happening, what's proceeding here. And if you look at the big weather picture, this is the surface analysis that was valid pretty close to the time of departure here at 0Z. The departure was out around that particular time, about a little after 1Z. So what you're noticing here is that there's a warm frontal system, and that warm front was moving to the north. So if you look at the warm front for the previous surface analysis 3 hours earlier, it was a little bit further south. So this warm air is moving in. So what a warm front is basically warm air moving over colder air locked at the surface typically. So we call that overrunning. That warm air is overrunning the cold air. And notice all this warm air coming from the south. This is essentially the southerly flow I mentioned earlier. So we have a lot of warm air flowing over that colder air locked at the surface. And yes, up further north, there was some freezing precipitation. There was some freezing precipitation up near Springfield and Lincoln in that area. And we're going to take a look at that in a bit. But that also means when you see this little squiggly line with that, you're looking at a freezing rain, or even if they showed you freezing drizzle, in that particular case, that's showing that you likely will have some kind of temperature inversion aloft. And yes, even colder, you see there's some snow up here further to the north. So yes, it was colder at the surface here and probably colder aloft in these areas. And we'll see that for this region up here near Springfield. But the warm air was riding up and over that cold air, and that was essentially happening in the big picture weather. And once again, this is not something that's not rocket science here. It's easy to confirm. If you're looking at the 850 millibar chart, which is roughly about 5,000 feet up, and if you suspect it, for instance, that, hey, it's the standard lapse rate, so at 4,000 feet, the freezing level should be around that 4,000 or 5,000 foot level. This 850 millibar temperature chart really clarifies that that was not the case. So this purple line that you see is the 0 degree isotherm. So that's the 0 degrees Celsius isotherm. And every 3 degrees you see these other contours. So that's 0, 3, 6, 9. So we're talking about somewhere the accident happened just to the west of St. Louis in this area here, that the temperature was at least positive 9 degrees Celsius according to this analysis from the North American mesoscale model. So this is a direct indication that you're dealing with a temperature that's well above freezing at positive 9 degrees Celsius at around 5,000 feet MSL. So if it were getting colder as you went up, you would expect to see this be near freezing, and it's not. So once again, you can really quickly identify what's going on by looking at the data itself. And it's pretty clear. And so when you look at the radar mosaic that has some filtering going on to filter out some of the non-precipitation returns, you can see there was some convection, and there was some convective sigmets. They're not shown, convective sigmets are not shown here, but there was some convective sigmets in this area. And that was much further south and east of the accident site. And so here's the St. Louis area. And so ultimately you see not much in the way of precipitation. There's a little bit here, and again, there were some areas of as that warm front moved in, there were some areas of very light precipitation moving into that area later on, but it was not freezing drizzle, because in order to get freezing drizzle, you actually need, at the surface, you actually need temperatures below freezing at the surface. So I'm not sure why 7 degrees would produce, positive 7 degrees would produce freezing drizzle. Maybe he was thinking freezing drizzle aloft. That's a possibility, but even so, there was not any rainfall at the time that there was that particular pilot departed. And so really what you need to understand, and this is kind of pretty easy to dig into, I decided to look at the 0Z radiosonde observation from Lincoln up near Springfield, Illinois. And they launch a weather balloon at the weather forecast office there. And there was one launched around 0Z. Now this is actually launched at around 23Z. So this is a couple of hours after, or before I should say, before the actual departure. But it's pretty representative of what was happening in that general area in terms of this warm air riding up and over the cold air aloft. I'm sorry, let me switch that away. This warm air riding over the cold air that's at the surface. And so let's kind of break this down and look at it in a little bit more detail. The winds aloft are not really all that remarkable, so I'm not going to really talk about them. Yes, you see the southerly winds right at the surface here, and they switch around to a more westerly flow. And so this is that warm air that's overriding the colder air that's locked in at the surface here. So a lot of cold air. And yes, the temperatures right at the surface here are right around freezing. So if this were precipitating in this area, and there were getting some precipitation in that region, as we'll see in a bit, that yes, it would, this is pretty deep. This is almost 9,000 feet of depth here. And as a result of that, you're probably getting a little bit of light precipitation in the form of freezing rain or freezing drizzle in this area. And it was essentially reaching the surface at a temperature that's just a little bit below freezing. So therefore, you're kind of right on the edge of having that freezing rain at the surface. But this was well over 100 miles to the north and east of the accident area. And looking at a temperature sounding like this gives you because this is actual a weather balloon that was launched, so this is really good information here. There are some issues with the accuracy at the top of this. We call this wet bulbing of the temperature as it pops out on the top of this. That particular case, you get a lot of evaporative cooling going on, and so you'll get these really sharp turns of the temperature at the very top of this. It's very common. It's an error in the sensor, but for the most part, there's not a lot of error in the sensor below this. We know why that happens. And notice that the temperatures almost reach, like I said, around 9 degrees Celsius, right around that 3,000 to 4,000 foot range. So this is really warm. So if you're climbing in this case here, and the tops are here around 9,000 feet, and that's up to the north where it's even colder, that further south towards that warm front, this entire temperature profile is shifted to the right by several degrees. And as a result of that, you're getting yourself into a position where climbing through this, especially with a temperature at the surface here around 7 degrees Celsius, you're climbing in nothing but air above freezing. And you can't, and I'll repeat that again, you can't get super cold liquid water and icing at those kind of temperatures. I don't care what you're dealing with here, you just can't get that. And so to me, this is very clear that this particular pilot did not find themselves in any kind of icing conditions. Even so, you have the situation where as that aircraft is moving through the atmosphere, there's some kinetic heating going on, and that heats up the leading edges, and it's really the air that's just above the surface layer of the wing that gets heated up. It gets compressed, it heats up by several degrees potentially. So again, that helps protect, and this aircraft in a climb was probably a little bit on the slower side, so maybe it wasn't really 3 degrees, it maybe was more like 2-degree protection. So you add all this together, it just does not smell like an icing environment at all. And here's the observation right around the time that the weather balloon was launched, pretty close to that area, and they were receiving some light freezing rain, overcast 500, and again, this kind of suspect here, +1, but if there's an actual weather observer there, they were actually going outside and looking, and yet they were seeing some freezing going on here at that particular point in time. But it's kind of very minimal. You would have to worry more about what's happening on taxi and initial takeoff rather than essentially what's happening 200 or 300 feet above, which we know is the temperature is warming up. So we're calling this basically a pretty significant inversion, and we don't get to the freezing level until at least 9,000 feet, and the freezing level near the accident site was almost 12,000 feet. And the way I know that is that you can look at the infrared satellite imagery here, and you can see that for the most part, this entire area from where the accident was in the kind of the lower left all the way up to where that radio sign was launched, the color of this, and this is just around the time of the accident itself, the colors are pretty much the same. So in that effect, the atmosphere is pretty much the same in that region. So I would expect that the radio sign observation further to the north and east would be pretty representative of what's happening down here, except we know it's warmer in this area here. And so we're talking about the cloud top temperatures, the colors that you see here, and certainly right around the accident site, the colors were likely around the +2-degree range at the tops. So it's still pretty warm at the tops of this, and we know there's a major inversion in that area. And just to clarify, there were no pilot reports of icing. In fact, there are a lot of negative reports of icing in these areas, but there was no reports of icing. I looked several hours before and several hours after, and this covers around the time frame of the accident itself. And if there was a freezing drizzle and an icing threat, the Aviation Weather Center would have issued some kind of advisory for icing at that time. And there was none because there was no risk of icing. This was issued at 2045 Zulu and valid at 0Z. And you can see that the only issue with respect to any kind of icing was really here in the much further to the east and north of the accident site. So in fact, there was no icing expected at 0Z all the way through until somewhere around the western part of Kansas and Nebraska here. So again, it doesn't show that maybe by the time they got to this point, I looked at the 3Z forecast here, and that all was moving slightly to the east with time, but there's no indication here that there was any advisory. There was not any SIGMETs for icing, severe icing. The GRMET here doesn't show any icing, and there were no pilot reports in the area for icing, and essentially no center weather advisories either for icing. So if there was a major icing issue in this region that could have caused an accident, especially related to freezing drizzle, that would have been shown by by one of these particular areas. The Aviation Weather Center doesn't miss this kind of stuff. They get it on the money, either by issuing center weather advisories, or when it's really severe, be SIGMETs, or essentially when you're dealing with just general moderate icing, these GRMETs get issued. So it's all the information and data points to a situation where there's really no chance of icing in this scenario. And I would fly, personally, I would fly in this region all day in the clouds, again, more worried about things like low visibility or lower ceilings rather than any icing in this case. So I think that it's clearly the case that the NTSB is not going to turn this into a major icing accident or incident. I think clearly this is a case where something else happened and could be weather related to, and I don't think there's a whole lot of turbulence in this area based on what I saw, but it's and given the fact that it was a really stable environment, likely not to have a turbulence issue, it could be related to something else going on in weather-wise in terms of IMC conditions or some other instrumentation failing. Could be an engine issue, who knows, but it probably is not going to be directly related to any kind of icing conditions. Wraps up episode 30 of Easy Weather Chat. My name is Dr. Scott Dennstaedt, and as always, I hope you enjoyed the simplicity of Easy Weather Brief.